This is Module 1, Lesson 8, where we are going to be making sure we know how to convert from scientific notation into standard form and vice versa. We're also going to make sure that we can choose the correct units for very large and very small quantities, particularly expressed in scientific notation. Now, scientific notation is a short way of writing very large or very small numbers. A number written in scientific notation has the form a times 10 to the nth power, where the a is between 1 and 10. Step 1, when you're converting to scientific notation, move the decimal so the new number is between 1 and 10, okay? It can't be 10. It can be 9, but it can't be 10. It's got to be less than 10. It's got to be greater than or equal to 1 and less than 10. Step 2, write using the power of 10. The exponent matches the number of times the decimal was moved. This is the important thing because people get that mixed up. They keep thinking it's equal to the number of zeros, but it's not. The exponent matches the number of times the decimal was moved. So if the decimal's moved right, the exponent's positive. If the number's big, the exponent's positive. If the decimal was moved left, the exponent's negative. If the number is small, the exponent is negative. Let's do a few of them here. We've got 540. We know the decimal needs to go between the 5 and the 4. So that's 5.4, and I don't put the 0 there because you don't have to put the extra zeros back there. 5.4 times 10 to the, well, this number is greater than 1. We're moving the decimal to the right. It's going to be a positive exponent. It's being moved 2 places. Times 10 to the second power. 937,000. Okay, you know there's an understood decimal there. You're needing it between the 9 and the 3. So I've got 9.37. Why did I do 2 places here, just 1 there? That's where my zeros start. So let's see how many places we're moving the decimal. Not how many zeros, how many places we move the decimal. 1, 2, 3, 4, 5. So this is times 10 to the 5th. And the exponent is positive because this number is bigger than 1. Big numbers get positive exponents. What about this number? We know we need our decimal right here, right? Because you need 1 digit in the front. That digit's got to be between 1, greater than or equal to 1, and less than 10. 1.852, see, that's where the 0 starts. So that's where I stop with my numbers. How many places do I move the decimal? Not how many zeros. 1, 2, 3, 4, 5, 6. This is times 10 to the 6th. It's a positive exponent because this number is bigger than 1. On 4, 76,820. That would be 7.682. See, I left off the 0. That's where I stopped doing my thing. My number in the front is greater than or equal to 1, but less than 10. How many places did I move my 0? Not how many zeros I have. How many places did I move my decimal? Sorry. 1, 2, 3, 4. Times 10 to the 4th. It's a positive exponent because this number is bigger than 1. 4,671. That would be 4.671 times 10 to the. How many places am I moving my decimal? That we understood decimal there. 1, 2, 3. I've moved it 3 places. It's positive because this number is bigger than 1. Let's look at 6. Okay. If we find the place we're going to put our decimals right there, so we can have 9.82. See, the first number is greater than or equal to 1, but less than 10. Now, times 10 to the. I'm moving my decimal 1, 2, 3 places. Okay, this number is smaller than 1, so it's going to be a negative exponent. Also, notice we didn't count the number of zeros we moved it past. We counted the number of places that we moved it, the decimal. Okay, on this one, our decimal is going to be here, so we can have 5.2. 5.273. See, that 5 is greater than or equal to 1, but less than 10. 5.273 let's see how many places we're moving the decimal, not how many zeros we've got, how many places I'm moving the decimal. I moved it 2 places. That's times 10 to the, is it a positive or negative 2? It's a negative 2 because this number is very small. It's less than 1. Okay? If we're doing this one, our decimal is going to be between the 1 and the 4 because that gives me a number up front that's greater than or equal to 1 and less than 10. How many places did I move my decimal? That determines my exponent. Let's see. I'm moving it 1, 2, 3. Whoopsie. 1, 2, 3. 1, 2, 3, 4, 5, 6 places times 10 to the negative 6. And it's negative because this number is less than 1. Okay. This would be 2.58 because the 2 is greater than or equal to 1 and less than 10. And I'm moving my decimal 1 place to get it there. Times 10 to the, and it's a negative number because this number is less than 1. Okay, on this one, I'd have 7.25. So I've got a number here that's greater than or equal to 1, but less than 10. How many places am I moving my decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9. Times 10 to the, and it's a negative 9 because that number, the starting number, the standard form, was less than 1, so I have a negative exponent. Down here it says determine if the number is correctly written in scientific notation. If not, correct it. This has got 1 decimal in the front that's greater than or equal to 1 times that. Perfect. Yes, it is. 11.4 times 10 to the 3. No, it needs to be 1.14, right? Because 11 is bigger than 10. I need to move my decimal 1 place this way. All right, if I'm moving it 1 place this way, this number is bigger than that, times 10 to the 4th. Remember, it said when I move my decimal left, okay, right, I'm adding positive. So it's 1 more positive, 1.14 times 10 to the 4th. There's also a thing called large that we're going to talk about again. If I move a decimal to the left, which I am, I add to the exponent. I moved it 1 place left, so I added 1 to the exponent. We'll talk about large. Large means if you move it left, you add. If you move it right, you subtract. That tells you when you're just moving 1 place what to do. Okay, here again, this one is not. We've got to move it 1 place because 85 is not between greater than or equal to 1 and less than 10. So I got 8.51 times 10 to the, I moved that decimal 1 place which way? Left. So I add to this exponent. -5 plus 1 would give me -4. So that's 8.51 times 10 to the -4. Is this one in scientific notation? Yes, the 6 is between, it's either greater than or equal to 1 or less than 10. And that's what we need for this to be scientific notation. Okay, we've talked about what scientific notation means. Are the following written in scientific notation? If not, state the reason. That one is, it's got the 1 decimal here, greater than or equal to 1, less than 10. So this one is. Is this one? No. Why? Because this 0 is not greater than or equal to 1. 0 is not greater than or equal to 1 and less than 10. Okay? How about this one? This one is. Is this one? No, look, they're adding, not multiplying. For it to be scientific notation, you have to be multiplying the number in the front times your power, 10 to whatever power. How about this one? No, because 18 is greater than 10, okay? Remember, this number has to be greater than or equal to 1 and less than 10, and this is greater than 10. 8 times 10 to the negative 11th? Yes, that one's scientific notation. Now, we're going to talk about choosing the appropriate unit of measure for very small or very large quantities. And these are just common sense. A teardrop, would I measure that in liters, milliliters, pints, or quarts? Think about liters. That's about like a Coke or a soft drink. Usually those come in 2-liter bottles. Pints, you know what a pint is. Jam often comes in pints. Quarts, you often have, quarts of milk, things like that. A teardrop is very small, so you would be talking about milliliters there. How about a pitcher of tea? Would that be the very small quantity milliliters, or would that be a liter? It'd be a liter, wouldn't it? Remember we talked about a liter, 2 liters is about what a Coke comes in. How about the weight of a boat? Grams, milligrams, or kilograms? Milli means something small. Kilo means something big. So the weight of a boat would be in kilograms. That's 1,000 grams. How about the distance a car drives after 1 hour of driving at normal highway speeds? Would it be in feet, yards, inches, or miles? Miles, I would think, right? How about the weight of just a grain of sand? Okay, would that be in kilograms? That's 1,000 grams. Would that be in grams, or would that be in milligrams? Milligrams means 1,000th of a gram. 1,000th of a gram. That would be very small, wouldn't it? So it'd be milligrams. And now let's look at just a few more things on writing numbers in standard form. I want to make sure you understand how to write them in standard form. If I've got a number like this and I'm trying to write it in standard form, times 10 to the 4th, that means this is a big number. I'll move this decimal 4 places. 1, 2, 3, 4. 29,500. How about this number if I wrote it in standard form? That means I need to move the decimal 2 places, doesn't it? Okay? 0.034. It's a negative number, so I'll make it a very small, it's negative exponent. I'll make it a very small number. When I've got this, guys, I can put a 0 in the front as a placeholder, in front of your decimal. Write each number in scientific notation. We've done this a minute ago. This is a large number, so we'd start with 9.74. See how many places we're moving the decimal, because that determines our exponent. 1, 2, 3, 4, 5 times 10 to the 5th. And it's a positive 5 because this is a very large number. This is a very small number. It's less than 1. It would be 1.6 because this gives me a number that's greater than or equal to 1 but less than 10. 1.6 times 10 to the, let's see how many places we moved our decimal, and it will be negative. 1, 2, 3, 4, 5. Oops, did I count them right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Times 10 to the negative 9th. And the exponent's negative because this number is less than 1. If I wrote this in scientific notation, it's times 10 to the 3. That means I'm making it bigger. 821. Now I'm going to move the decimal. The decimal's understood to be there. I'm going to move it 3 places. 1, 2, 3. Okay, I know this did not start out as scientific notation, but they're asking us to write each number. Oh, wait, they wanted us to write it in correct scientific notation. Sorry. Let's fix that. Okay, I was just giving you the actual number. Let's write that in correct scientific notation. Large lets me do that. Okay. I gave you a term earlier. It's called Lars. Lars means it deals with moving our decimal. If I move a decimal left, I add to the exponent. If I move a decimal right, I subtract from the exponent. Left, add. Right, subtract. Okay, this is how we handle moving the decimal whenever and changing the exponent whenever numbers are not straightforward. In this case, to write in correct scientific notation, I'm going to need to move the decimal 2 places, right? I moved it left, didn't I? If I go left, I add to the exponent. I move 2 places, so I add 2 to the exponent. 3 plus 2 is 5. 8.21 times 10 to the 5th. Let's do the same thing here. This is a negative exponent. Let's use Lars. I'm going to need to move this decimal 1, 2, 3 places, right? 4.5213 times 10 to the, and I moved it how many places? 3 places left. Left means we add. So I'm adding 3 to this negative 5. Negative 5 plus 3 would give me negative 2. How about this one? It needs to be 6.7 to satisfy the fact that this needs to be greater than or equal to 1, but less than 10. Okay, now I have moved this decimal 1 place, right? And I moved it 1 place right. If I move right, I subtract. So 4 minus 1 gives me 3. 6.7 times 10 to the 3rd. And then how about this one? 2.3. Okay. I'm moving this from 1, 2, 3, 4 places, right? I moved it 4 places. Which way did I move it? I moved it right. So I need to subtract 4. I have negative 1 minus 4. We talked about if we're subtracting a number, we rewrite that as an addition sentence. Keep, add, opposite. We keep this. We change this to addition. We look at this number here, which is a positive 4, and we use the opposite, okay? Negative 1 plus negative 4 is negative 5. 2.3 times 10 to the negative 5 power. Lars. When moving the decimal, remember the phrase Lars. Left, add. Right, subtract. If you move the decimal left, add to the exponent. If you move the decimal right, subtract from the exponent. Okay? That covers everything that we're going to do in this particular lesson. Go look at your homework, and best of luck. Let me know if you have any problems.